Imagine you're holding a hot cup of coffee in a cold room. After a while, the coffee cools slightly until both reach the same temperature. Why does this happen? Why doesn't the coffee get hotter or stay hot forever? The answer lies in the fundamental laws of thermodynamics. A pleasant day. I am Benj Allen Odinson. Today, we'll explore thermodynamics together with its four laws, understand their meaning, and see how they explain the world around us. Thermodynamics is the science that explores the relationship between heat, work, temperature, and energy. It's explained how energy is transferred and transformed from the form to another, and how this process dictate the behavior of everything in the universe, from engines to living organisms. Let's begin with the zeroth law of thermodynamics, the foundation of temperature. It states if two systems are each in thermal equilibrium with a third system, then they are at thermal equilibrium with each other. This law allows us to define and measure temperature. Next, the first law of thermodynamics, also called the law of conservation of energy. It tells us energy cannot be created or destroyed, only transferred or converted. The change in system's eternal energy equals the heat added minus the work done by the system. The second law of thermodynamics explains the direction of process and introduces entropy, a measure of disorder. It says energy transformations are never 100% efficient. Someday energy always becomes less useful, often as heat. In any closed system, entropy tends to increase, meaning system naturally move towards disorder and equilibrium. Simple example, if you open a perfume bottle, the scent molecules spread out into the room, moving from ordered state inside the bottle to disordered state, filling the space. They never spontaneously gather back. The third law of thermodynamics talks about absolute zero and entropy. It states that as a system approaches absolute zero, the lowest possible temperature, the entropy of perfect crystal approaches zero. This means the system becomes perfectly ordered. Simple example, water cools from steam to liquid to ice, become more ordered at each step. At absolute zero, molecules would be motionless and perfectly arranged with zero entropy. In summary, the laws of thermodynamics are the invisible rules behind every energy charge in the universe. They explain what your coffee cools down, why engines need fuel, and why disorder tends to increase over time. Understanding these laws gives us a powerful way to see and predict how nature works. That will be all my report. Thank you for listening, and I hope you found the explanation informative and insightful. That's all. Thank you.